All right, let's talk exponents, because that's the next step that we're moving towards when we're talking about rational numbers and irrational number unit, or our real number unit. So exponents, you guys pretty much know the basic idea of it. We discussed it a little bit at the beginning of the year when we talked about orders of operations. An exponent is basically you have a number like 3, and you have an exponent, like maybe it's a 4, that's in the corner. So 3 is called the base, your base number, and then the 4 is your exponent. And this exponent basically it represents the multiplication that's occurring over and over and over again of the base. So this would be 3 times 3 times 3 times 3. And notice that the 3 has occurred 4 times. So you're multiplying your 3 over and over and over and over again, however many times your exponent tells you to. Okay, so that's the basic idea of an exponent. And in this case, this would be equal to 81. Okay, I'm going to show you a couple of examples of how to write something that's in expanded form and put it into scientific or into exponential form. So if we have something like -4 times -4 times -4 times -4 times -4 times -4. So I'm repetitively multiplying the value -4. That's my base. So my base is a -4. My exponent, in this case, is how many times the -4 repeats. 1, 2, 3, 4, 5, 6 times. So my exponent is a 6. Now, because my base is a negative, I have to put that in parentheses because this is indicating that it's the entire thing, the negative and the 4 are being repeated. Excuse me, 6 different times. So that's what it would look like in exponential form. -4 inside parentheses and the exponent 6 on the outside. If I did not put the negative inside the parentheses, that would actually change your answer. See, a -4 inside parentheses is going to come out to a positive answer. If you did not have the -4 in parentheses, you would get a negative answer. Let me show you what I mean with the calculator. So I'm going to type -4, and then to get my exponent, you see this arrow, this little above arrow right here in white? If I press that, it now lets me place an exponent there. And I want to get out of there. So right now I have -4, and the negative is not inside the parentheses. It's just -4 into the 6th power. I'm going to get a negative answer. See, -4,096. But I know that if I multiply -4 times -4 times -4 times -4 times -4 times -4, I'm going to get a positive 4,096. So the difference is that when I didn't have the parentheses, I wasn't including the negative in my multiplication. It was only saying that 4 was raised to the 6th power and that your answer would then be negative. So if you want to make sure that that negative is part of it, you have to put the parentheses and then type -4. Then you close your parentheses. Then you can put your exponent. Again, this is your exponent button, your little up arrow, and then a 6. There's your positive 4,096. Okay? All right, let's do another example. Let's say that we have 2/3 times 2/3 times 2/3. See, this is another one of those kind of weird examples. Again, I have 2/3 as my base. My base is 2/3. My exponent in this case is the amount of times it repeated, which is 3. So again, this is another one of those problems. I have to put it inside of parentheses, 2 over 3 inside parentheses, and put it to the third power. If I did not do that, if I did not put the parentheses around it, then the only thing that would have that exponent is the 2. The only thing that would wind up having that exponent would be the 2. Okay, so you want to make sure you put that in parentheses. It's 2/3 raised to the third power. All right, let's do one more. Let's say we have 2 times 2 times 2 times 2 times 2. Okay, again, I want to put this in exponential form. So here my base is the 2. That's the value that's being repeated over and over and over again. My exponent is how many times I'm having that repetition happen. So 1, 2, 3, 4, 5 times. So in exponential form, that would be 2 to the 5th power. All right, so that's the basic idea of exponents and how they work, and again, how to use an exponent on your calculator. You type your number, let's say, okay, let's go back with that 2. I want to put it to the 5th power, so here's my exponent button. It's that little white up arrow, and then a 5. There's my exponent. If I want to get out of the exponent, because notice the cursor is still flashing in the little exponent box, I just have to use these gray arrows to get out. Push to the right, it gets you out of it, and your cursor is back down to flashing in the normal spot. You hit enter, and there's your answer, 32. 2 times 2 times 2 times 2 times 2 equals 32. Okay? All right, now we're going to talk about some exponent rules. I'm going to introduce to you a couple of little exponent rules today, and they should be relatively easy rules. So the first rule that I'm going to talk to you guys about is called a product of powers. So let's say that I have a problem like 3 to the second, and I want to multiply it by 3 to the third. And I want my answer to be in exponential form, meaning I don't want to know, I know 3 times 3 is 9. I know 3 times 3 times 3 is 27, and then I could do 9 times 27. I don't want that. I want my answer to be a base and an exponent. So how would we go about doing that? Because if you use your calculator is going to give you a final answer like this. Your calculator will not give you an exponential answer. So what do? We follow a rule, a product of powers rule. So let's break this down. 3 to the second power. If I want to break 3 to the second power down, that becomes 3 times 3. And then let's go ahead and break 3 to the third power down. This becomes 3 times 3 times 3. So now I have the problem of 3 times 3 times 3 times 3 times 3. Well, all of these are the exact same base, aren't they? They're all 3s. So I know that I have a base of 3. And then for my exponent, I just have to see how many there are. Well, 1, 2, 3, 4, 5. Here's my exponent. It's a 5. Now, I broke it all down here, but what if I didn't want to break it down? Let's take a look at just the problem and see if we can figure out what the rule would be. If I have 3 to the second, and I'm multiplying it by 3 to the third, and I get 3 to the fifth, notice the bases did not change, right? Both bases were a 3. My answer's base is a 3. But my exponents changed. I had a 2, and I had a 3, and now I have a 5. Well, what can I do with the 2 and the 3 to get a 5? I can add them. I can add those exponents together, and that would give me the 5. 2 plus 3 would equal 5. So when we're multiplying like bases, when multiplying like bases, you keep the base and add the exponents. When you're multiplying like bases, you keep the base and just add the exponents. Let's take a look at another one. Let's say we have 14, and it's being raised to the 5th power. And then I want to multiply it by 14 to the 3rd power. Now, based off of the rule that I just wrote, if I'm multiplying like bases means your base is identical, then all I have to do is keep that base and add the exponents. So all I would have to do is keep this base. My base is 14. So I'm going to keep 14, and then I'm going to add my exponents. So I'm just going to add 5 plus 3, which gives me 8. So I'd have an exponent of 8. And that would be my final answer. Well, let's check. Let's make sure. We always want to make sure that this is true. Okay, so 14 to the 5th power. That means I'm multiplying 14 times 14 times 14 times 14 times 14, right? 1, 2, 3, 4, 5. I've got 5 14s right there. Then I'm going to go ahead and multiply it by 14 to the 3rd power. So let's write 14 to the 3rd power out. 14 times 14 times 14. Okay, I've got all these 14s, so my base is 14. And let's count how many there are. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 14s. 14 to the 8th power. Let's take a look at another one. Let's say that we have 2 to the 15th power. And I want to multiply it by 2 to the 21st power. I'm using really large exponents because I don't want you writing all of these out. I want you to follow the rule. When multiplying like bases, those are like bases, you keep the base, so I'm going to keep that 2, and I add the exponents. I'm going to add the 15 and 21 together. So I have like bases, those are my like bases, and I'm just going to add these exponents together. So 15 plus 21 is going to give me 36. So I have 2 to the 36th power. So that's product of powers. When we're multiplying like bases, we add our exponents. So let's take a look at some quotient of powers. So the quotient of powers is similar. It's very, very similar. So let's say that we have 5 to the 4th power, and we are dividing it by 5, which is 5 to the 1st. So 5 to the 4th divided by 5 to the 1st. Let's write it out. 5 to the 4th is 5 times 5 times 5 times 5. 5 to the 1st is just 5. So for every 5 I have on top, I can eliminate it with a 5 that I have on the bottom. A 5 on the top and a 5 on the bottom, I can cross those off. I have nothing left on the bottom anymore. So when I don't have anything written there, I just automatically can go ahead and assume it's a 1. Right? It's the same thing if I say, oh, 2. 2 is a fraction. Well, you know it's 2 over 1. Right? The 1 is not written there, but you know that 2 over 1 exists. So we put a 1 there. So now I've got 5 times 5 times 5 over 1. I don't have to write that though. I can just say it's 5 to what power? Well, let's see how many are there. There are 1, 2, 3. So 5 to the 3rd power. Let's see here. If we didn't do this though, how could we take the problem and get to the answer? So what do we know? We notice that both of these had the same base of 5, and my answer had a base of 5. We notice that these exponents were a 4 and a 1, but now my exponent is a 3. So what could we do with the 4 and the 1 to get an exponent of 3? Subtract them. If we just subtract, 4 minus 1 gives us a 3 for our exponent. 4 minus 1 gives us an exponent for 3. So the 5 is going to stay the same for the base. You're just taking your exponents and subtracting them to get the 3. Let's take a look at another example. Or actually, let's first write the rule, okay? When dividing, like bases, you keep the base and subtract the exponent. All right. When dividing like bases, you keep the base and subtract the exponent. Here's another example. I have 7 to the 5th power, and I want to divide it by 7 to the 3rd power. 7 to the 5th divided by 7 to the 3rd. All right, let's follow the rule. when dividing like bases. Are these like bases? Yes, they are both bases of 7. So they are like bases. That means I'm going to keep the base. So I'm going to have an answer of 7 for my base. And I'm going to subtract the exponents. So I'm going to take that 5 and subtract the 3 to get a 2. So my exponent is going to be a 2. My final answer is 7 to the second power. 7 to the second power. Let's double check it for good measure. Okay, 7 to the 5th. So that means we're doing 7 times 7 times 7 times 7 times 7. And we're dividing by 7 to the third power. So 7 times 7 times 7. Right? Remember, for every 7 on top, you can eliminate it with a 7 on the bottom. So I have 3 pairs I can eliminate. That leaves me with 7 times 7 over 1. 7 times 7 is 7 to the second power. All right, let's try another one. I'm not going to show you an example like this, so I'm going to make the numbers really large. So we're going to say it's 218 to the 19th power. And we're going to divide it by 218 to the fourth power. Okay, 218 to the 19th power divided by 218 to the fourth power. Again, I have identical bases, so I know my final answer is going to have 218 as the base. I now need to subtract the exponents. When it's a division problem, we subtract the exponent. 19 minus 4 gives us 15, so our exponent is 15. 218 to the 15th power. Okay, you guys are going to do some practice now with IXL. Well, you'll be practicing some exponents, product of powers, and quotient of powers.